welcome to the Artifact Design Studio. I'm Russ Hockenberry, and today I am joined by Christina Block, who's the rock star librarian at Norton Commons Elementary School, and she is bringing a lesson called Coding Unplugged, Kindergarten Coding Explained.
All right, today we're going to be talking about a kindergarten coding unplugged lesson. We talked about a lot about how coding is so great for these younger grades for computational thinking, but that we really wanted to make sure that they understood what these symbols mean and that we put it together to make movement and create code, as opposed to just knowing that to make a game work, I can move these arrows almost like a toy. So we wanted to teach those algorithms and that way of thinking. So we started at the kindergarten level with the alphabet. This was whole class. The kids were at the tables and I was up at the front. We talked about how we know alphabet letters make up different sounds, and when we put them together, we can decode them into words. We can create words together. So, for example, I use cat, ha, ah. When I put those letters together, I can sound out cat.
Great stuff, Christina. Let's talk now about how this lesson hits the Kentucky Academic Standards for Computer Science. It fits mainly under the category or concept of algorithms and programming.
When it comes to coding, and the reason this is so great is because students that are not necessarily successful with the alphabet can be successful with this new coding robot language. We talked as a group what symbols we wanted to represent our new alphabet that we were making for robots. So we knew we were going to be building towers with cups. So we decided that the up arrow should mean up, the down arrow should mean down, new row should be meant with star. And the kids decided that those are things they can draw and that it's age appropriate. So then we decided that we were going to actually start coding robots. So we modeled this at the front of the room. I had a kid come up and show them how to build a simple tower by giving them directions. We also talked about how robots do not have brains, so we cannot do what we know what we should do next on the tower building. We have to build based only on the code that they write down, because that's how computers work. So we paired groups. I did that with the help of the teacher to make sure that we had groups that could work together. I got out design notebooks, which are just notebooks that with scrap paper, and I used tiny cups as supplies. The cups were good manipulative so that the robot person really was focusing on showing where the code was in the sequence. And then explain roles.
So how did you pair up your kids?
One person was a robot. One child was a robot. The other person was a computer programmer. The computer programmer was responsible for writing the code, and the robot could only follow the code as it was written. So if the person said, for example, pick up a cup, the robot had to sit there with a cup up in the air until the computer programmer said, put the cup down. As far as the towers go, we started super simple using this Tinkersmith coding unplugged task cards. So this is an easy one. There's three cups, and all the cups are facing the same way. So we modeled this one together, and then I erased the code on the board, and the students were able to replicate that in their notebooks. As they finished, the kids raised their hand and we checked their code and work, and then they switched roles. So the other person became the robot, the other person became the computer.
So how did you differentiate for your students?
For differentiation, the kids that were ready, I gave harder task cards to. So I passed these task cards out. Some were ready, some were not. And with some of the task cards, they actually had to make up new symbols to flip the cup over for the code to work.
Good, Aryan. Oh, you can't set it down, robot Aryan. What does he need to do with that cup? All right, Aryan, there you go.
All right, so up next, I had a let's practice slide. We decided it was time to actually practice this independently now that we've done this model whole class, work as a group with teacher feedback. So every student in the class got a paper, a simple paper, no big deal, with their name. They created their key, they wrote their code, and then they drew a picture of what the tower they were trying to code looked like, the 3-cup tower. There were some that were able to do a little bit harder, but we focused on the 3-cup tower so that we can make sure all the kids could do it independently. So what this was teaching was, the focus of this was computational, not just computational thinking, but also communication. I can speak in this language that the computer is coded in, because I feel like if they can articulate it, they really understand what they are doing. So we use clips to show our learning, and I modeled for the students what the video should look like in order, just to kind of give them a frame of reference. But they're talking and speaking. It wasn't always perfect, but it was student-led and student learning, so I let it be how it was. The students were mostly correct in their building and coding towers. The video and computational communication added another element that sometimes tripped them up, but was all part of the learning process. So here I have a student that's going to explain to us her coding tower and her work, and then where she put this in the backpack.
Hi, my name's Maya, and I'm going to teach you my coding sentence. Up, down, new row, up, down, new row, up, down, up, down, new row, up, down. I chose this one because I learned something new.
Here's another example of a student with a different backpack skill that they chose.
My name is Gideon. I'm going to teach you my robot sentence.
Go.
Up, down, new row, up, down. Up, down, new row, up, down. This because it was something hard, and I just had to stick with it.
Okay, I really like that because the students were able to select their own area where they grew the most and put it in their backpack if they chose to do that. Here I have an overview of the project. It's a Coding Unplugged movie. Grade level was kindergarten, although you can make it harder and tier it for different grades. There's not much required, which I appreciate. You basically need cups, paper, and one iPad to be able to do the clip as they film and finish. It speaks to some computer science standards as well as AASL standards. I pulled some main ones, but this, goes into even more than that if you really wanted to pull some more standards.
So how long did all this take? What was your timeline on this?
So the project timeline, I took 4 classes and collaboratively taught it with the teacher. It is important to have another person while you're pulling kids to do recordings because you do need a quiet space. That can be a challenge. But as they finished, we just let them select their backpack folder, and then they were able to upload from there right as they finished their work, which was very authentic. And then one of my favorite things that I got from this project was I had a kindergarten teacher email me about a week after the project was over and send me this picture of their daily calendar. And what they do is they look for changes each day with their butterfly. And they noticed that the butterfly was changing shape, kind of like our computer code. So I was not in this room. The kids were able to point out that they saw the same algorithms and coding sentence structure that we used with our tower stacking, and they were able to label that you needed to go to the new row. The butterfly was now upside down, then over to the left and up, and the next day they would go over. At the end of the week, they would put new row. So I thought that was a great connection that they were able to take back to their classroom, and to me, that represents authentic learning. Of course, we are going to code robots and get to do other different games, code.org and Scratch. They've done those things, but I felt like this was a great example of authentic learning and application. So that was really powerful.
So let's talk about where this fits in the SAMR model for technology integration. Where this really fits is between the augmentation and modification areas. Though the students are not using a computer to program, they are using a computer programming model and explaining that through clips. By video recording themselves, explaining their process, this brings it into the A and M area of the SAMR model.
So I hope you enjoyed this lesson, and feel free to use this within your classroom and differentiate to make it appropriate for all grade levels.